In this presentation, we will be calculating current through individual components in a parallel RC circuit using those pieces of information to build a current triangle, and then using the total current to calculate impedance. So we're going to be using Ohm's law and calculating the current through the individual branches first. So we'll be applying Ohm's law in two different locations. We want the current through the resistor. That will be equal to E divided by the value of the resistor, or 120 volts from the source, divided by the 45 ohms of resistance, and that will give us a current flow of 2.67 amps, and that will be the resistive current on the adjacent side of the triangle. We can calculate the capacitive current, and that will be source voltage divided by the capacitive reactance, or 120 volts divided by 35 ohms of capacitive reactance, and that will give us a current flow through the capacitor of 3.43 amps. Now that we have two sides of the triangle, we have the adjacent and the opposite, or the resistive and the reactive side. To calculate the total current, we can use Pythagorean's theorem, which would be the square root of IR squared plus IC squared. Put in the values, that would be 2.67 amps squared plus 3.43 amps squared, and that will give us a total current flow for this circuit of 4.35 amps. So now we have the total current flow in this circuit. We can now use that piece of information, because we cannot build an impedance triangle in parallel, and we can calculate the impedance just from the voltage and the current. So Z, which is your total opposition, will be E total divided by I total, 120 volts divided by 4.35 amps of current flow for the total. The impedance in this circuit is 27.58 ohms.